Welcome. Today, we're diving into Claude Code 2, Anthropic's latest leap in AI-assisted software development. This isn't just another incremental update. It's a bold reimagining of how AI can transform the way engineers tackle complex coding challenges. From onboarding new developers to orchestrating massive refactors, Claude Code 2 promises to change the game. But does it live up to the hype? Let's break down what's new, what's different, and what you need to know before bringing this tool into your team's workflow. Every engineering team has that dreaded refactoring project, touching dozens of files, updating countless call sites, and hoping nothing breaks in production. New hires often struggle to navigate sprawling code bases, and debugging legacy logic can feel like deciphering ancient scripts. Claude Code 2 claims to tackle these headaches head-on, promising smarter code understanding and automation. But before we get swept up, let's see how it addresses these real-world pain points. So, what sets Claude Code 2 apart from other AI coding assistants? The answer lies in its architecture. With a massive 200,000 token context window and 64,000 token output, it can process and remember entire applications, hundreds of pages of code, configs, and docs. This means the AI doesn't forget critical details mid-task, a common flaw in earlier tools. In theory, this allows for seamless, context-aware code generation and refactoring. But does this translate to real reliability? That's the question we'll keep coming back to. Let's unpack the idea of context windows. Previous AI tools struggled with memory. They'd forget your architecture after a few minutes, leading to inconsistent or even contradictory code. Claude Code 2's expanded context window means it can see your entire project at once. When you ask for a refactor, it understands every place a function is called, every dependency, and every relevant test. This could be a game changer for multi-file coordination, but only if it works as smoothly in practice as it does in demos. One of the most exciting features is Agentic Codebase Search. Instead of telling the AI exactly which files to look at, you describe what you need, and Claude explores the codebase autonomously. For onboarding, this means a new developer can ask, "How does payment processing work?" and get a mapped-out workflow from API gateway to billing and notifications. This could cut onboarding time from weeks to hours, provided the codebase is well-structured. But how does it fare with messy, real-world legacy code? That's still to be seen. Agentic Search isn't magic, it's an iterative process. The first answer might be too generic, so you refine your question. With each follow-up, Claude digs deeper, providing more specific and useful answers. For example, tracing the entire authentication flow, including token refresh logic and error handling, becomes a back-and-forth conversation. This mirrors how real developers learn, but with the speed and breadth of AI. Still, its effectiveness on complex, inconsistent codebases remains an open question. Claude Code 2 claims to coordinate changes across dozens of files, maintaining consistency and type safety. This directly addresses the nightmare of large-scale refactoring, extracting shared utilities, renaming confusing functions, or breaking apart monolithic code. The AI builds a dependency graph, plans changes in phases, and presents diffs for your approval at each step. This workflow could finally make those daunting refactorings manageable, but only if the AI reliably catches subtle dependencies and implicit couplings. Even with advanced orchestration, there are risks. Codebases often have hidden dependencies, runtime expectations, configuration quirks, or shared mutable state that static analysis can't catch. If Claude misses these, it could introduce subtle bugs that only appear under specific conditions. The promise of safe, automated refactoring is huge, but it's not a guarantee. Developers must still review changes with a critical eye, especially when dealing with legacy systems. Claude Code 2 touts the ability to maintain focus over 30 hours of cumulative work. Imagine delegating a sprint-level task like migrating a service from REST to GraphQL and having the AI handle schema design, endpoint updates, tests, and documentation. The model tracks milestones, manages context, and even lets you rewind changes instantly. While benchmarks show promise, real-world projects are messier, with shifting requirements and incomplete documentation. The 30-hour claim is impressive, but it needs validation in production. Claude Code 2 introduces thoughtful command features for developers who prefer keyboard-driven workflows. The tab toggle lets you switch between fast execution and step-by-step reasoning, helping calibrate trust in AI suggestions. The divided by usage command gives real-time insight into token consumption and costs, while the agents flag enables parallel task execution. These features reveal a design philosophy focused on giving engineers control, not just automation. The balance between autonomy and oversight is key to safe adoption. Adoption friction kills even the best developer tools. Claude Code 2 integrates natively with VS Code and JetBrains IDEs, providing workspace awareness, inline suggestions, refactoring previews, and Git integration. This means developers can stay in their familiar environment, reducing the learning curve and boosting productivity. The tool even automates issue triage, code fixes, and pull request creation. If it works as advertised, this could save hours per task. But as always, reliability in real-world scenarios is the ultimate test. Security is a top concern with autonomous coding tools. Claude Code 2 uses permission gates. Every significant action requires explicit developer approval. File changes are shown as diffs. Terminal commands need confirmation, and network requests require authorization. Developers can restrict the AI's access to sensitive files, and all actions are logged for compliance. However, permission gates don't eliminate all risks. Subtle bugs can still slip through if developers trust the AI too much or skip thorough reviews. Claude Code 2 doesn't just change how code is written. It impacts team dynamics, knowledge sharing, and skill development. When AI generates large portions of code, traditional review practices may fall short. Junior developers might appear productive but miss out on deep learning. Knowledge sharing shifts from informal conversations to AI queries, which can erode tribal knowledge. Teams need to rethink mentorship, review processes, and documentation to ensure long-term effectiveness and growth. If you're considering a pilot, focus on specific evaluation criteria. How accurate is agentic search in your codebase? Does multi-file orchestration catch all dependencies? Can the AI maintain focus on complex, shifting tasks? What are the real costs? And how does code review quality change? For individual contributors, test Claude on your toughest tasks and track time saved versus time spent correcting mistakes. For leaders, ensure your team has strong review processes and test coverage before scaling up. Claude Code 2 represents a genuine shift from autocomplete tools to autonomous coding systems. Its capabilities, agentic exploration, multi-file orchestration, extended operation, and deep IDE integration are impressive on paper, but reliability in messy, real-world projects is still unproven. The best approach is careful experimentation, robust review, and systematic evaluation. Don't rush into adoption, but don't ignore the potential either. The future of AI-assisted development is here. Let's see if it lives up to its promise.